So we already have it. So we don't need this at the moment. And we're going to get back to our cluster. Okay, my cluster got in deep sleep mode and check again. So let's go to the next step. The next step is to download this repository to the Amazon Cloud Shell, so we can interact with that. So we're going to ROS example, and we need to, let's see, we have nano here? No, we have B. Yeah, we have B. So the ones who are not familiar, who are not comfortable with B, because it's a little bit scary for the newcomers, you can do yum install -yes nano. Nano is okay with sudo. And you have nano. Nano is more friendly. Use whatever you want. I'm going to use in this state B in order to show any different. And we're going to KHS, and we're going to do Docker first. So CD. And now we are B Docker. What is okay? B Docker, and we have to go here because we have to change the name of this. So with B, you have to do the sorry, I know I am already editing. So we're going to puzzle. Okay, we're going to puzzle these push commands. I'm going to put this one. So copy and puzzle. So I'm going to do this and copy this for the other deployment. So no, sorry, I am okay. This is okay. We are nano. So no, I found that a little bit confusing. Okay, we have this. And yes, and now we're going to the listener. This time I'm going to use B. Listener. Okay. Now with B, you have a prettier thing, but I'm going to delete this line and insert a new line. I'm going to puzzle this and exit 2 points. Right key. So let's take a look at the Docker, and we have here, and let's go to the listener. Okay, so in order to deploy this, let's go back to our repository. We have the instructions, and well, I was in the right folder, but here, and kubectl apply, first the Docker, here, first Docker, and here, the listener, here, the listener. So let's go and do kubectl get pods. And you see that the listener and the Docker is creating. I'm going to do the watch magic in order to wait till this is ready. So, well, for the ones who are not familiar with that, this is it's an example ROS node. The Docker will send a string, and the listener will listen the string and print it. So the idea, I'm going to check if everything is okay. I think so, but we're going to describe this in order to And after what's I continue, describe talker. So I want to check if everything. Oh, sorry. Oh, this one here. Copy. Puzzle. We don't have. Sorry. I have to determine that this is a pod. Something easy to forget. Okay. Everything is working. So, okay, we have it. So one thing you can do first is to give CTL get logs. Let's go. I'm going to find my commands. That's why I wrote it. So let's go to, we're going to get the logs with the label app talker pod. So let's go close here and put this. And you can see, hello, Guillem, my name, or whatever you put. And this is a timestamp. Let's go to the listener and see if listener pop. And I heard this thing. Well, we are good, but maybe you are wondering if the other pods can get that. So we are going back to our SSH node here. Well, I lose the cubes, CTL, get pods, and we're going to select this one. Cubes, CTL, exec minus IT. I'm going to copy, not the other time, copy, puzzle, minus bash. Okay, so, okay, I'm going to try this, minus user ROS, no, let's go with the root. I'm going to source the ROS point, okay. So let's see ROS topic. Let's see if we can see the other topics. So we have the robot. We have the chatter. Okay, this is and we're going to check if the node is up and running. ROS node list, and we have the nodes. Okay, we have chatter and we have talker. So let's do a ROS node info and see what is the subscriptions. And so this ROS node is publishing on chatter a string and is subscribing to the clock and something that the internet that it will need. And let's go to the listener. Okay. So this is the opposite. It's publishing on ROS out, but is subscribed to the chatter. So let's see if we can read the chat of these two nodes. So let's go and ROS topic echo, and we're going to do chatter. Okay, we have it. So within another pod, within another EIP, within another machine, we can access to this node. So if you develop any ROS node, you can place it on this, and you can do a distributed placement of this robot applications. So the idea in order to do that is to allow you to develop. You have a ground base to develop your own applications. So as you can see, you don't need a special machine. You don't need to have a special OS installed like ROS Melodic or Ubuntu 18.04. You don't need nothing like a credential and of our Amazon Web Services, and you can deploy a cloud simulation without the need of having a local machine. So we covered several things. First, we covered, as my colleague was saying, to log in and create the default resources. After we deploy the machine, the simulation, and we create a custom node. This is a very simple example, but we create something that you could be as complex as you want. So, and the most interesting thing I think we achieved is we deployed in our Kubernetes cluster effortlessly. So you don't need to, of course, if you have something more complex, we need to handle the manifest files, but you don't start from scratch. You have something from you can start. And not only we deploy this, so we can see that everyone else inside the ROS in the ROS bus can see the messages, so we can interact. Also, here we can interact with the localization. For example, we can see the ROS topic list and see it was MCL, right? It's MCL post. That's right. Okay. We can see ROS topic echo. Let's go only once, but I'm going to put the auto-completion robot MCL post. So we will see that here we have the post here. This is 3 meters X, 3 meters 1.7 meters Y in referring to this frame ID, and with this orientation with quaternions that are quite easier to understand to the robot, but not quite easy to understand to the people. But and this is the covariance of the estimation of the position. So we have an estimation of how accurate we have the position, and the robot is still here. And I think that's it for the moment. The only thing we need is to clean it up, but I wanted to leave this slot to open an open mic to ask questions, comments, difficulties you have, some trouble you have to do this, and we are happy to hear from you.
Sorry, just before the questions, I want to close the gap with this workshop and the 5G-ERA project. So what we have shown in this workshop, and also what we are trying to do in 5G-ERA project, is that, okay, we have a robotic platform. We know that a robotic platform is running a lot of processes, is wasting a lot of resources. So we want to, in this project, what we have shown in this part of this we have shown in this workshop, we want to take advantage of the 5G infrastructure to have all these processes running inside the robot distributed in different machines. So in different computer, whatever, how you want to call it, different nodes, so that we can have each of nodes is a less powerful node that can run a single process. And to do this, we need an orchestrator. So what my colleague Guillaume has shown here, we are using the Kubernetes orchestrator to have this robotic platform distributed, and to have each project, each service running in different nodes that can be whatever inside the network, maybe even in different networks, but this is the next step. And having this, you